So you've realized that my role is to leave you with 2 crisps and a Robert sandwich. The joke is always a risk, but that one wasn't too bad. So I want to talk to you about natural language generation, or NLG for short. So I'll use the acronym to save me saying natural language generation frequently. And there's really 2 things I want to do in the next 10, 15 minutes. One is to demonstrate to you that NLG is a commercially viable and commercially useful technology. And the second thing is to try and emphasize the importance that the technology can play in enabling a multilingual digital signal economy. So I think it's really important to see how NLG fits into that picture, and I'll try and draw that out a bit as I work through these slides. Most people are familiar with machine translation. We've been talking about that a lot at this event. Most people are familiar with natural language understanding technologies like text analytics, sentiment analysis, information extraction, and so on. But fewer people are cognizant of what's been happening in the NLG space. NLG has been very much a kind of sleeper technology. We started doing work in NLG in the 1980s, but it's always played a relatively small part in the wider NLP community. And I think now is the time that's going to change, and it's going to change because of the way the data landscape is changing around about us. So I see NLG as a missing link. It completes a triangle. At the top of that triangle, we have text-to-text technologies like machine translation, summarization, and so on. We have a whole host of technologies that take text and extract from that text data or information. So that's your text analytics, sentiment analysis, and so on. And what NLG is doing is adding the third side of that triangle and taking not text to produce data, but data to produce text. So that's the function of the technology. Of course, we've been using technologies that take data and produce text for a very long time. And if you think back, maybe some of you are not able to think this far back, but if you go back to the 1980s, there was indeed automatic text production technologies around then. But they were called mail merge, right? You took a spreadsheet that had a bunch of data in it. You took a Word document that had slots in it for the person's surname and their address and so on. And you basically just ran a script that populated Word documents from your Excel spreadsheet. So that's what automatic text production looked like in the 1980s. This is what automatic text production looks like today. It's a much more sophisticated beast. I'm not going to go through this diagram in any great detail, but simply by showing you the exploded parts of this engine, I hope you can see that there's a number of quite sophisticated stages involved in going from data to text. So on the left-hand side there, we have a bunch of machinery that takes raw data, produces data abstractions from that data that you might think of as facts. We have inference and reasoning that takes those facts to work out significance and importance to produce what we call here messages, pieces of information that can be conveyed via language. And then we have a whole sequence of linguistic processes that take those pieces of information and work out how to craft a text that delivers fluently, articulately, concisely the information that's in those messages. And that requires the applications to know something about document planning, how you structure a story. It means it has to have knowledge about how you put information together to build complex sentences. And of course, it needs to know the rules of grammar and morphology to be able to produce appropriately correct sentences in the final output that we produce. So it's a way more complicated technology than where we started 30 years ago. Why have we had to develop such a sophisticated way of going about converting data into text? The reason is the data landscape has changed. If you go back again to the 1980s, the distance that data had to travel to become a document was not very great. If all you're doing is populating a document from a spreadsheet, all you have to do is reach into that spreadsheet, pull out that particular piece of data, put it in your document, and you're done. Today, the landscape is very different. The data that we deal with is way more granular. Many of the applications that we build, for example, are dealing with sensor data, often sub-second sensor data from thousands of sensors on multiple pieces of equipment. All that data has to somehow be massaged, cajoled, collated, summarized, compressed down into a piece of information that means something to a reader. So the distance the data has to travel from its raw form to the text it ends up in is way more complex, more longer than it was before. The other thing that's changed, of course, is the depth of the data. So what I mean by that is the range of data sources that you then have to feed in to produce something of meaning and value. So a much more complicated landscape in going from the data to the text. And I'll come back to some examples that maybe make this a little bit clearer. So the challenge then that the NLG technology tries to address is how do you deliver information from those sorts of data sources to people in a way that they can use. Now, you might say, oh, that's easy. You use a business intelligence visualization dashboard tool thing, you know, and we present a screen with lots of graphs and charts, and because a picture speaks 1,000 words, it's all solved, right? Well, some pictures may speak 1,000 words. They certainly don't all do so. And I certainly would agree that if you just want to track the performance of a particular stock in the stock market across some period of time, then a line graph is, no doubt about it, the best way to show you what's happened to that stock price over that period of time. But as soon as you start to add more data to that, more stocks, looking at different portfolios, complicating the scenario with other financial instruments, even reading the graph becomes a chore, becomes very, very hard. And you get this problem that sometimes it gets referred to as dashboard fatigue. So you present such a dashboard to a manager, and they look at it, and their eyes glaze over, and they say, yeah, but tell me what it means. And of course, the way that we tell people what things mean is to use language. And that's, again, what NLG is trying to do. It's trying to take those data sources and present the content in those data sources in a way that makes meaningful sense to people. Okay, so some examples to try and make this a little bit more concrete. The first one here is some work that we did for the UK Met Office, Meteorology Office, some years ago, and this application is now running on their website. Prior to the use of NLG technology, the Met Office had a room of meteorologists who would write what are called site-specific 3-day forecasts for about 60, that's 60 locations around the UK. Birmingham, Bristol, Brighton, London, Aberdeen, York, Dundee, Glasgow, Sheffield, and so on. 60 places were privileged enough to get a weather forecast written by a human that said what the weather's going to be like today, what it's going to be like tomorrow, and what it's going to be like the day after. Now, the reason the Met Office produced 60 of those things is not because that's the granularity of the data that they have. The Met Office can actually give you an individualized weather prediction to a 10-kilometer square. The data they have is astounding. The models they have are phenomenally detailed. But clearly, there's no economic case for providing weather forecasts quite as detailed as that. However, if you automate the technology, then it's easy. So now if you go to the Met Office website, you can type in your postcode in the UK, and you get a weather forecast automatically generated for that specific location on the map. And of course, this scales easily to the entire planet if you have the data to support those forecasts. So scalability achievable through this technology in a way that you simply could not contemplate using human authors. Second thing that a typical NLG application brings is what I'm calling here expertise automation. Now, you probably can't read the text on that screen, so I apologize for that, but I think it's probably the case that there will be slides on a website somewhere after this event, and so you can zoom in and have a look at this if you're interested. The context here is Gulf of Mexico. This is some work done with a major oil and gas provider who operates out of the Gulf of Mexico. Situation is we have very large pieces of equipment on oil platforms, compressors, pumps, generators, some of which have a footprint about the size of this stage. They're massive pieces of equipment. They cost tens of millions of dollars. A big compressor may have 120 sensors on it, taking readings for pressure, temperature, movement, vibration, and so on. Again, often sub-second readings on those 100+ sensors, just for that one machine. All of this stuff is streaming back to a control station called the Bridge in New Orleans. It looks a bit like the Star Trek bridge, lots of screens all over the walls and lots of engineers watching what's happening to all this equipment on all these platforms across the Gulf of Mexico. There's a fairly simple kind of expert system in play that looks for breaches of thresholds. So if something gets too hot, just one sensor, or a couple of sensors just vibrate too much, an alarm sounds. Well, a red light comes on the screen. There are lots of red lights because in that industry, for reasons I'm sure you can well understand, they play very, very safe. So there's lots of false alarms, and the thresholds are set very low. The engineer's job is to work out which of these things have to be looked at in more detail and then to write up a report that describes the situation that he or she thinks gave rise to this circumstance, and a recommendation for the operator on the platform to do something, which might be switch this piece of equipment off, replace a part, or ignore it because we've seen this before and it's not a problem. But the engineer has to produce the report that justifies that recommendation. And in some cases, this can take 2 to 3 hours to produce because of the quantity of data that the engineer has to survey to work out what might be going on with this piece of equipment. And then they have to write this up in a report that makes sense to a third party to read. Again, with NLG technology, you can replicate that entire process in 60 to 90 seconds. You can sometimes do even better than the human engineer does because they're under time pressure. The software isn't. It can look at more data points. It can produce more insights into what might be going on. Third case here, I want to emphasize here another important capability of NLG, which is tailored reporting, using a common data set, a single data set, to produce different reports for different people. So this is an application built for the Royal Infirmary in Edinburgh in the UK called BabyTalk. It's a system that takes, again, sensor data, a bit like the oil and gas case I just described, but it also takes medical records and other kinds of data that have been provided by doctors and nurses, and it produces in a neonatal intensive care unit where you have a prematurely born child, again, covered in sensors, giving off data. It takes the data in that context and produces reports, but different reports for different people from the same data. So it produces reports for doctors that tell the doctor what's been going on, produces reports for nurses who are ending a shift and handing over to the next nurse who comes on, and it also produces letters to the parents of the child saying what's been happening to their child. As I'm sure you can imagine, especially with the last of those three, the language is very different in each case. But it's all produced from the same underlying data sources. So that's the problem that NLG addresses. It addresses use cases where we have data and a gap in communicating what that data means to somebody, a user or reader or audience who needs to know what that data means. The way an NLG application does this then is it takes that raw data, it analyzes and interprets that data to produce what you might think of, if you like, as information and insight, and then it uses linguistic processing to take that information and insight to produce from it fluent, coherent narrative text, multi-paragraph text that explain what's going on. So, very near the end, where do I see this going? So here's my predictions for what I see as the future of information delivery in the large. This isn't just ultimately about producing language. There are lots of other ways of communicating information, but language is a very key one because it's one that we as a species have evolved for so long to be such a precise instrument. So 5 predictions. I have to put my glasses on because I can't read them without them. So we are in a world of data overload. We are surrounded by data. We've heard that many times. We've heard about big data for a long time now. In the big data future, in the data overload future, the ability to communicate about the data you have as a company, as an organization, will separate you from those who lose by not being able to do so. Being able to communicate the information that's in your data becomes crucial. It will be an important determinant of success. You'll be aware, probably, maybe, there are a number of companies now operating in this space of NLG. And what we're seeing quite a lot of now is what I'm calling here robo-writing or automatic journalism. So this is typically things like stock market reports and sports reporting and so on. That's where you'll first see NLG appear on the public landscape into public visibility. But I think very rapidly what we'll see is a bifurcation in the space where this technology is used, so that there are lots of these relatively simple and cheap robo-writing applications, and then there are more precision NLG applications where getting the wording just right is really important. Third prediction is that enterprises will adopt what I want to call a multilingual NLG ecosystem, something that's baked into the organization at every level as a means of communicating their information. So it's not a world where you'll have simple little single isolated in their silos NLG applications. Communication is so crucial, it will become a layer in the stack that organizations use to interact with the world. NLG capability will be taking those organizations' data and producing language artifacts from it. More generally, so I've framed all this in terms of the category that we now have, natural language generation, I think that category will disappear and will be replaced by what I'd like to call multilingual information delivery. Because that's the end goal of all this kind of activity, being able to take data in some very abstract form, extract the information from it, and present it to whatever audience needs that data, irrespective of the language that they speak. I won't flip back to the NLG engine architecture I showed you earlier, but you might remember it had 5 pieces in that diagram, that pipeline that I showed. To turn this technology to use in another language only requires changing the very last of those pieces. That's the only piece that has the grammatical and morphological knowledge of the language that you're producing. The rest of that pipeline, pretty much, is common across all languages. So it's not a big task to take an NLG application and make it multilingual. Last prediction, by 2020, there will be more text out there written by machines than there will be text written by humans.